Hello, everybody. Welcome to Rocket Lasso Live, episode 25 of season 3. The episodes are just flying by really, really quickly. I've got, well, I guess the first order of business is the camera is working again. It turns out that the capture card was completely fine. It wasn't broken. A Windows update changed the input settings on like the fundamental camera where it cranked the saturation to 0 and the brightness up to max. As soon as I set it to default, it popped back in as normal. Literally settings I had never seen before, so thank you, Windows. And what else? Well, last week, Mesh the Spline came out, the newest Spline plugin from Rocket Lasso. So that's exciting. That's out there in the world. I think there's a link below. Go check that out if you're inclined. Other than that, it's a regular episode. So start getting your links together. If you have a link to, well, I'm going to be answering Cinema 4D questions. If you have a question, then feel free to post a link. If you're on YouTube, you can't post a link. You have to type out a question. If you want a URL to be shared, then you have to go onto Twitch. You should find a link below if you're on YouTube. But either way, if you do post a link, I need to see the artist or studio who made it. If we can't give credit, we will not be tackling it. But I do like typed out questions, so don't be shy about doing that. If I don't get to your question right away, I tend to jump and skip around in the chat, so feel free to post it as I'm wrapping up one question. Post it again, just don't get spammy. Also, something people have been doing a lot lately, which I do appreciate, if somebody asks a question and you yourself go click on the link, you're like, ooh, that's cool, feel free to second it and be like, oh, like, go, I really like Sean's link, like, and mention it again. So I'll go and look for that link if multiple people seem to be keeping an eye out. But in general, I try and reach for new names I haven't seen or people who don't typically ask questions. So I want to cycle around. We do it all off the cuff. I have no idea what questions are coming, so it's fun. It's a good challenge for me. It keeps my skills sharp, and it's a way of helping the community. In general, I get a lot of random questions on all over the place via email or social media or LinkedIn or Twitter or Instagram. I get questions all the time. If I spent a lot of time answering them, I'd be doing full-time tech support for Maxon. So obviously that's not viable. But compressing it all to a 2-hour live stream, I feel like that's the way to go. The goal today will be, let's tackle a bunch of questions, not spend too long on any given question. I'd like to tackle as many as possible. So that's an idea. While we're on just kind of covering news items, I would like to pop open a scene file. So I have a Patreon set up. And on Patreon, I run bonus streams. Usually, under normal times, there's a bonus stream on Tuesday and a bonus stream on Thursday. And we tackle different things on different days. And we've had an ongoing project. It's been like 9 episodes in a row where I have been modeling like gemstone, like different cuts of precious gemstones. And it's been really fun. And we're wrapping it up. And I've just been trying to build out some materials. So just as a bit of fun, I'll share this and open up. So we are getting very, very near the end of the process here. And this isn't like specifically prepped for today's live stream. That is not the correct file. Oh, here it is. 0C. Okay, so there's a collection of all of the different gemstones. So let me unhide this. This is the very raw file. But you can see here I've got all these different gemstones. I spent a bunch of time modeling them, super clean, super accurate. I might go and do some UV unwrapping on them, but we've got the heart cut and an ice cushion cut and an emerald cut, the standard diamond cut. There's all these different ones all cleaned up. They'll all be set up and prepped. So I've been making a bunch of materials to go along with that. And something I'm kind of excited for is I spent a lot of time over the weekend working on a kind of master material. And these are just redshift, but I spent a lot of time making like a super material in redshift. And the idea being, I still have to clean this up. It's kind of more in this raw form. But the idea is that you can make any gem material that you want, be it cloudy or shiny, whatever the different index of refraction is. The idea will be that all you have to do is play with these couple of green settings as far as like what colors it's supposed to be, what is the index of refraction, and then how much imperfections do you want, how cloudy should it be. So just controlling all of that via just a couple of settings. So I'm pretty excited for that. It's not going to render super quick because it is a fairly complicated scene, but let me see if we can just take a look at one of them really quickly, just for fun. And I'm going to be making these files available on Patreon, so anybody supporting there will get access to the final files and all the materials. It'll be all cleaned up by the time that happens. But in any case, here is that super material. Apply, let's make sure that that is applied here. And so here's the pear cut, and open up our Redshift render view. See if we can get that to look all right. It's going to take a little while to render, and I need to clean up that material so it optimizes. But with that material opened up, I could grab, let's see, let's simplify. So here's a cloudiness. I can say no cloudiness. And yeah, so right there, this is just the basic color with no variation. So we say, okay, this is supposed to be some sort of, let's say, ruby. So I can crank the red up, just a little bit of darkness there. And yeah, so we get, boom, instant ruby, ready to go. But then let's say it's kind of an imperfect one. So I can say, hey, I want a bunch of cloudiness in there. So if I put 0.2, then that is going to become way more opaque. Not totally opaque, but we could crank that up to 1, and that's very, very opaque. Still a little bit transparent, but let's pull back on that. Actually, we'll go to 0 on the cloudiness. And then with the imperfections, I'm going to say, okay, give me maximum imperfections. And now you see the entire thing is getting super, super chopped up. Let me isolate that to maybe render a little quicker on there. And yeah, you see it, we get tons of imperfections layering up on top of that, but it's all about how these things start combining on top of each other. So let's go easy on the imperfections. So let's say 0.25, and then let's do a little bit of cloudiness. But here's where things get fun, is if you take a gem like this and then you sort of shatter it, and in this case, I just throw it to a Voronoi fracture, and if I turn that on, then it's going to break it apart into all of its individual pieces. And let's make sure that this is, I want to just have barely a little bit of cloudiness. I want to see it pretty transparent. And now you can see that we get these individual fractured sections, and you get the individual cracks, and I've got all sorts of noises offsetting how each piece is viewed and putting tiny little hue variations in there and just different noises to make them compatible with real world scale. Just tweaking things, you should be able to kind of put them together and make exactly what you want to make. It's just been a fun process to put together. Pretty much the entire process has been documented for the people on Patreon, where all those, you know, all the recordings we made, all of these from scratch, kind of different techniques on every single one. So I learned a lot along the way, and it's just been fun putting this together. So I just wanted to share. That's going to be wrapping up soon and become available on Patreon. So just something neat. So yeah, let's close that up. Just a little something or other. And let us move directly into the chat and start checking out questions. Or even say some hellos. Let's see. We got people on YouTube. We got people on Twitch. Mike, what's going on? Is that a second Mike? MB or MPB? Mitya or maybe Mitya? Welcome. Seems like a new name that I've never seen before here. Melvedo. Bihavna. RBLX, of course. And, ooh, I think an Indian name I can't possibly read. Bobby, Iron, what's going on? And Sid, Dean, Matt Dog, Spear Factory, Crossfader, Tobias, all the regulars, Monthys, Mick, Sean, Clarky, what's going on? Sam, Intelligent Machine, more names popping in every second. Mr. Falcon, welcome, that's a new name. Actually, I don't recognize Mr. Falcon as a question, so I'm going to try that question first. Normally, ooh, that's dangerous, but let's see what you've got. Normally, this would be done with particles, but how would I tackle it? So let's see what we got here. Let me mute that just in case, and let's see what we got. I have even though I don't put advertisements on these episodes, I have gotten like copyright strikes because of the copyrighted music that we play, so I make sure to mute everything. All right, what do we got? We've got Netflix The Crown. This one is very primed for us getting copyright claims, so I'm going to make it relatively tiny here. So the opening to The Crown, music. Okay, so there's not a studio specifically, but it is the TV show The Crown. So let's see what we got. You linked specifically to this time code, so I'm assuming you mean this time code. Yep. So I actually have tackled things along these lines. Actually, this is a good excuse to maybe do a tiny little bit of Ricochet, but I want to do it vanilla first, and then maybe we'll take a look at doing something like this with Ricochet as well, because I always like talking things vanilla for people who don't have any plugins. So yeah, there's a beautiful like title sequence. It's kind of like a wax look, but I think it's molten gold. So you can see we get this nice growth happening. And I think it's actually a really good situation for doing things like a controllable rig. If you were to do that type of thing with particles, everything gets very, it's based on the simulation. Like what you get is what you get, and you have to resim everything. But building rigs is really nice here. And something important to keep in mind is every time this is actually a trap I fall in a lot, which is, let's take a look right when it starts. So we're here, and you've already got this long strand going, and it's all out of focus, and you see a couple spreading out. But to me, in the past, I would spend a ton of time just trying to make like a master rig, like one rig that will do all of this. And it's almost like, okay, you're just cutting the different parts in different moments. But every time there's a cut here, there might be a completely new rig. So this could be completely rebuilt from scratch, having almost nothing to do with the previous shot. So trying to do everything in a single shot is probably not a great idea. Having said all of that, let's pull this to the other screen and see if, scroll. Okay, just make sure we're here. Let's see if we can make something along these lines. Now, what's my first thought? I definitely used that as some rough inspiration of a little bit of the animation in the Ricochet ad. I'm trying to think of how I might do it without any plugins. Well, let's start with a Helix, perhaps. So yeah, we'll do a Helix and make it 1,000 long. And I don't want too many spirals, so we'll cut that in half. So a single kind of partial spiral. Here's the basic idea. If we throw that into a cloner and set the cloner to radial, change the axis to, I'm not sure which one, we'll just guess until we get it correct. There we go. So based on this one, you see I've got a nice spiral going. If we set the radius to 0, then we'll just have 5 of them in a row, each doing their own thing. We can make exactly whatever count we want to make the spiral. So already kind of a cool looking shape. And now we could keyframe this to have some variation. Here's one of the thoughts though. Maybe I'll step back a second. I want to have a partial growth on this thing. So it's a little bit of a pain to animate this forward, because if we increase, let me turn it off. I want to step by step this. If we increase this radial angle, you'll see that that will spin around, but it's not getting any longer. Essentially, we have this line, and I want to stay on this line. So how do we lengthen it along that line? Well, something we might do is, it's a little convoluted, but inside of the MoGraph menu, we have a MoSpline, and the MoSpline can be set to spline mode. That spline mode can now reference a external spline, being this helix, hiding that original helix. You see I still have a spline showing up. It is the MoSpline. That MoSpline can be said, hey, just return a line. So now I've got just a line going. And with just that line there, now we have the ability to play with the start and end. So if I start pulling back on this, you see I can rewind on that without, I'm just pushing it forward along the helix instead of having to rewind it in some odd way. Now, I don't know how well this will blend. If I throw this in the cloner and clone it around, does it work? Yes, that does. Now, the next question is, can I make a duplicate of that MoSpline and partially go back? And yes, good so far. You can see that, every other one is half erased out. But now, inside of the cloner, I can say, hey, I would like to blend between these two. So clones blend, and perfect. It's still continuing to work. So now it's blending from one state to the other. So now we can say, hey, these can go as short as 0, and then they slowly transition to the end. So having done that, what if we don't want these to be in a linear line? Well, there's a very specific setting inside of MoGraph. And how do I want to do it? Do we do it directly with a random? No, we'll do it with a plane. Almost always, I'm only ever using a plane effector these days. I've mentioned it before, but it's so crazy that originally there was no such thing as a plane effector. That didn't exist. To make a plane effector, we used to, when it first came out, you would make a shader effector and put no shader in it, just like a white color, and that was how you would make a plane effector. So with a plane effector, I don't want to affect the position. But what I do want to affect is the weight. No, is it modify clone? I think it's modify clone. I want to affect the modify clone. But right now it's just a plane effector, so this is probably going to make them all uniform. Whatever I drag this to, they all become exactly the same. But by setting that to 100%, under the fall off, I can feed in anything I like. In this case, how about a random field? And the random field is currently based on noise, but I'll say I want it to be random. And now, by setting it to random, what it's done is it's randomly assigned a different value. So instead of it linearly transitioning from one side to the other, we now have random points anywhere from as small as 51% to as large as 100%, all thanks to the modify clone. You'll see if I drag this down, that becomes weaker, weaker, weaker. If you go to 0, it'll suddenly pop, because at 0 it means it's not applied at all. It's just whatever you're getting from the cloner. As soon as you go to any amount not 0, now it's overriding it 100%. So now all of them are randomized, and now I have different lengths going. We have the ability to keyframe each of those at the same time to make them animate forward. And now that that's happening, they're all they are a little uniform, but we can do some simple things like I will do a random effector directly on here. And that random effector, actually, yeah, positionally changing it is nice. I'll keep that. And then we can change the scale. We could do it in uniform ways, totally valid. So I could uniformly scale up and down a bit, but we'll turn that off and let's just scale on Z a bit. So I could scale that a little bit on Z, make some shorter, make some longer. An important one here for a uniformity, or getting rid of uniformity, would be turning on rotation and spinning on, hey, I guessed right, spinning on B, and now they're all randomly spinning based on that radial, so now they might end up at any random angle, and you end up with a very controllable twist. Now, what's really cool here is we have so many different properties we could go and manipulate. The helix is still the original shape, and it's still live. I can say, you know what, there should be no rotation to that. Let's see, yeah, it took a second to refresh. I think we want a little rotation, so let's say as small as 90. And now you see they twist just a little bit, or we could go back to the original 720, and they're all twisting a whole bunch. So I still think 360 was a fine look for that as it was. Let's get a couple of keyframes going. We'll just allow keyframes to be the primary driver here. So actually, when it comes to a MoSpline, you can we overshoot? Yeah, what's cool is the MoSpline can even go beyond 100%. It will start going into these crazy twirls, which is, depending on what you're doing, can be good, can be bad. The twirls are a little crazy, but you do have control over those by your extend start and extend end. So if we twirl those down, and Cinema very infrequently has these twirl down properties, but it is a cool thing you can do. So yeah, here is extra things you can do after it. So we've got all this curl and scaling and spiraling, but if we start zeroing those out, you can see that we can calm those down a bit, and they won't get as crazy depending on what you have going on. But we also don't need to extend it. So my thought is this is where it will look in the way it will look in the end. So I'll just keyframe both of them for their end. We could also keyframe the offset to keep that in mind. But rewinding the beginning, I would like, let's just rewind this one all the way to 0 and this one down to 50. So both of them are back about half the amount. Those are not linear, so they're going to accelerate and decelerate in, which I didn't mean to do. So I will select the first one, hold down Shift as I select the other one. Actually, that doesn't work, but you can select the empty spot and hit Control A, which will select everything, and then say, hey, those should be linear. So now those will be moving at a constant rate as they move around. So, you know, this is a clean, basic setup, a lot of variety that we can add into it. We could even, right now these are both based on that same helix, but keep in mind we could even make a second helix. So one of them is based on one helix, the other is based on the other. That secondary helix could have a smaller radius of, let's say, 55 by 55. So now we can get some smaller lines eating up the inside here, and you still have that randomness creating them. Create as many copies of this as we want to get that full transition between. It does feel like we're getting a rough transitional. Why isn't it blending perfectly? Maybe, oh, I know why it's not blending perfectly. I wonder if do you see right now it's not blending perfectly? It feels like we have a cluster in the middle and a cluster on the outside. Well, that's because the cloner is blending between different parameters. And it's trying to currently blend between the source helix, but that can't be blended. The source helix is an object. So right at the 50% mark, which in this case would be half of the clones, it's going to suddenly pop from helix 1 to helix 2. There's no transition in between. Having said that, is it possible to make these children, and yes, I thought that might work, by dropping the helixes in as well, they are also getting cloned a bunch of times, meaning they get to transition their parameters as well, and we do get that perfect blend. So yeah, those helixes did work for us there, and we get the full blend. There's a lot of clones now, so this might not run nearly as quick. There's actually a lot of points. I'm going to simplify. So this uniform 8, I'm going to say none, no in-between points. And both of these MoSplines are each creating, I thought there was maybe it creates the exact amount. I thought we had control over the point count, but maybe it takes on the point count of the object it is copied onto. I'm just going to assume that. So there should be, Still not as quick as I thought it would be. But yeah, you can see we have a very controllable rig to have as much of this spreading out as we want. Then, so obviously in the reference here, it is, where's the reference? We've got a lot of twist to it. Like there's a big bend in that. But honestly, it goes to, you should build this. You should build this as clean and simple as we can. And in this case, it's just a straight line traveling forward. Now that that's happened, we could, the simplest would be create a bend. This would be a valid use case to use a bend object. Creating a null, feed in everything that's relevant to it. Drop the bend in as a neighbor. Rotate that to the appropriate angle. And I'll just scale it to whatever scale. And by bending that, give it some bend. I'll say -90. So it goes down. I tend to turn on keep length so it doesn't stretch as it goes. And even something else I like is set the mode to unlimited, meaning that the curve will continue forward and backward from the bend. So this is just sort of representative of the type of curve we're going to get. So now we can go pretty mild on the bend, but you can see we get a nice curve overall. So hiding the bend, just so it's not in the viewport, we see we get this curling downward. It will still animate. The bend is a static object, so that's not going to refresh on us, and we can just blend in between there. And now that we get this final crazy shape going, what just happened? I think I dragged something. The bend behaving a little oddly on our object. It seems to be, the MoSplines seem to be getting affected, or I bet you, I don't know for sure, but the bend might be applying to the final MoSpline, but also the internal Helix. So there's like a double effect. So I wonder if we can add a stop tag. I don't know if I'm trying to think of the last time I used this tag ever, especially in the live stream, and I don't even know what folder it's in. Where would it be? Animation, hair, no, modeling tag, maybe, yeah, stop. So here's a stop tag. Yes, okay, it did work. So you'll see what this is doing is it's stopping generators and stopping deformers. So let's, oop, that's interesting. Nope, no, it's not quite. It's still, you see how it like refreshes weirdly when I drag my mouse over the viewport? So it's like, oh, that seems fine, but when I mouse over, it suddenly pops back in again. That tends to be that there's some sort of feedback loop happening here. A thought I have would be putting this maybe into a connect object. If that gets baked down into a single object, does it stop the feedback loop from happening? Seems to. When in doubt, use a connect object, although it does seem to have, did it make twice as many of them? It's hard to tell. Yeah, it seems to be showing the original and the not original. Yeah, that's getting kind of crazy. Yeah, by making the helixes children of it, like it both gave it a benefit, but also a limitation. The stop tag seems to calm it down a bit. So maybe the stop tags were creating a problem there. Maybe the stop tag, oh, the stop tags with generator turned off might have been stopping them from getting affected by the connect object. So maybe this is working again. But actually, they're not blending now. No, oh, there is still an original one. I think, oh, the connect object. Yeah, this is trickier than I thought because the connect is now seeing the helixes because those are children of it. And the cloner needs to blend between them to see both of them, but they're continuing to get created. And I don't, we can't like disable them because now there's nothing for those to get, oh, okay, that was a shot in the dark. I thought there's a small chance that would work. There's a chance that I just made it work because the MoSpline can see the calculated helix even if it's been turned off, and because the MoSpline is a like crazy weird tool that behaves not in the ways you necessarily expect. So we just hit caveat and then solution, caveat, solution, caveat, solution, to where we have now successfully bent and connected this, and it seems to be stable. All right, with that connected, I would think we can feed the entire thing, hopefully, into a volume builder. And yep, okay, volume builder working just fine through the null. That gets put into a volume mesher. And now we end up with the final blob here. The defaults actually worked well for the current setup. So you see we get this pretty decent geometry. It's not overly complex. A little more detail would be good. It's going to kill our playback, but by lowering that, the resolution increases on our mesh. And then the null, which is, yeah, it is coming in as a spline, which is interesting. Set the density to 1, so we're calculating it accurately. And the radius, let's try 7. Yeah, 7 seems pretty good. So we can see we've got all these individual lines traveling along, doing their thing. But the animation, which I think we got more tendrils than we need because there are nowhere near that many here. But clearly there's like some drippy bits near the end. So first of all, if we don't need to be more complex than the reference, so let's simplify. We don't need as many lines. And if we don't have as many lines, we'll make them larger. So there we go. That should go a little bit quicker. So how can we get the tip of these individual lines to get a droplet? Well, we should be able to do that in a pretty straightforward way, hopefully. We'll see if this cooperates. Create a sphere, put that sphere into a cloner. Clone onto what? I want to clone onto an object. The object, let's see if it can interpret this connect object properly. I'm not sure that it will. Yeah, that doesn't seem to be seeing it terribly well. We get the bend. You know, it's something that probably would work is putting that entire null with the bend. Well, actually, the bend could go into, well, the bend's acting on the connect. I'll just feed that entire thing into another connect. When in doubt, use a connect. So it's been fed into a second connect object. And now, can the cloner view that secondary connect object? Yes, it can. Excellent. So, yeah, when in doubt, use a connect. So now we got 10 copies per line. I'm going to say I only want 1 copy per line. You see it's at the beginning, but if I say, hey, don't loop, it's very important to turn off loop here, and then offset of 100%, and it's now creating a sphere on the tip of every single one of those edges. T for scale, to scale these down. You can see we got an individual droplet now on the tip of each. We could randomize it to the scale. We won't worry about that for now. Drop that into the builder, and now we got the bigger fat droplet on the end. This entire thing could get a smooth. Definitely add some calculation time on. Let's pull back on the strength here. You see that can do some smoothing for us, but there's not enough geometry to justify that in this case. So I'll use one of my favorite smoothing deformers, and we'll drag that in as a child of the mesher, and now those will all blob way nicer into each other. You want to get your volume correct. Right now I'm at such a low resolution that we get these pretty bad pops in between. If we cranked it up so that there was more subdivisions, that would help a lot. But this smoothing is going to do a really good job of rounding out these droplets. Kind of, even though those shapes kind of weren't matching each other at all, I could keep on dragging this up and up and up. And as I go, you see that these droplets get really sharp and you get these nice, like crisp, smooth shapes. And there's a little bit of back and forth you can do where I've super smoothed that out, but we could then reinflate it a little bit. So that can be done multiple ways, but since we're using all these effectors, I'll say plane dot deformer. I'll drop that in, and what should that be doing? Well, I want it to be deforming the points, and that's going to make that kind of explode. But if I say, hey, don't be on Y, instead just be on Z, now you can see I can tick this up, and as I do, it's going to start pushing those out individually, like every single polygon is pushing back out again. So it's kind of counteracting the smoothing by reinflating. But you see that this droplet is still super smooth. So a combination, I often will do some smoothing and then reinflate, and then it's not unusual for me to make another smoothing where I only put a couple iterations, but now that I've reinflated, just a little bit of smoothing again will just round out any parts that got kind of weird and started like intersecting themselves. So yeah, that's kind of where I'm at. So now we get this awesome, crazy, blobby thing. I have not saved, so I should probably do that. Jump into scene files for, what is that? Oh, it looks like I might have duplicated. I think I accidentally duplicated one of the. I didn't duplicate an empty folder. I duplicated one of the previous ones, so I have to delete all these out. That's, yeah. These are the files from last week. So give me one moment. Copy that destination. I'm going to go into a new file explorer, and then delete all of those out. delete. There we go. And now I can save it. Okay. Sorry about that. Let's see. I'm just going to call it Gold Blob, even though ours is not gold. Gold Blob. These scene files become available on Patreon because of the product launch. I'm a little behind on that, but I was working yesterday and today to try and get caught up on those. Now, as I said, we have a lot of layers here doing a lot of things. So actually, now the playback's not that bad. I think we made less copies, so I can drag all right. And yeah, now you can see we get these individual things growing and swirling. If you were to just cut to this for like 2 seconds and then cut away, like that will give you your shot as, you know, if we go with the proper framing, like pretty much nothing will be here in the scene, and you can just let them start slowly snaking their way in. Keep in mind, we could... you could do more like branching off of layers, or we could do some distortion here, like deform them so that they're not all just perfect swirls. But in this circumstance, the perfect swirls are working just fine. So yeah, that is an idea of the rig. I don't want to spend too long on it, but let's save that. And as a completely alternative build, I just want to give you a quick demo with Ricochet, which is a plugin that we make now, or that we have from Rocket Lasso. So here's a torus shape, and I want to make a bunch of lines bounce around inside of that, kind of like a particle system, but I want to have control over them. So here's the thought. I will make a, well, let's just go step by step. Extensions, Rocket Ricochet. So that's our plugin that we released about a month ago. And if I were to take this and drag it into the object, I can now make the torus a child of the Ricochet, and you can now see I have a spline bouncing around inside of it. So if I increase the length, I'm going to get more and more and more bounces. So we can add an extra 0 on there, and we could add another 0 on there, and you see I get tons and tons of bounces, completely filling up the torus shape with a crazy spline. So that's all good. But in this case, I would like to create a matrix object. So now there's a matrix created. I'll temporarily turn off the Ricochet so we can see. And I want to take this matrix object, set that matrix to radial, and now you see I've got a tiny radial of these, and I'm going to reset a bunch of these values. Probably should have made this from scratch. Reset the default. Okay, so you see I've got some clones. I want to make more, and currently they are all aiming on presumably Z, so they're going to be shooting straight out. So if I were to activate my Ricochet, you see a bunch of lines shooting straight out, and it'll bounce off if it bounces, but we want those to aim upward, and I'm not sure what angle that is, so let me aim that up. Yeah, so I'm going to aim these upward, so they're all straight up. Cool. So now you see I've got that radial shooting up. If I now scoot this inside of that ring, we get a bunch of start points, and it's going to be bouncing off of the wall. So you can imagine, let's randomize that a bit. So I'll turn on this random. I don't want very much randomness, so we'll just say, I don't know, 15, 15. So those are spreading out a little bit. So now if we were to select our Ricochet and change the length, I can pull these all back. So very quickly, without a particle, I have 100% control over the way these lines are traveling, and we could animate that forward doing the bouncing. So you see how quickly I was able to get these all to the state where it's like, oh, they're all just going into the scene. I can keyframe these the way I want to. I could say, hey, that's a start point, and twirl down the length and give it some rate. So I'm going to be like, okay, it's got some growth speed now. So hitting play, those will automatically grow. They're actually really quick. Actually, I don't want rate. I want growth. So we'll just do a little bit of growth. Let's say 155. Hit play, and now those are growing automatically. If we want to round those out a bit, I can go under my spline and enable a B-spline. And now those get curvy. We can subdivide as much as we want. So now we get those stretching and traveling through. Or we could do the same MoSpline trick to have them drive as the points are changing. You see those bending and changing. I don't think today's an appropriate time to do a preview of some of the upcoming things. I mentioned it last time, but we'll just wait for those to come out. So yeah, we can get, well, there's an upcoming smoothing spline that we could smooth this out as it goes. But yeah, we can have these bouncing around, get control over those. And this spline can immediately be thrown into a volume builder, volume mesher. Clean those up a bit. 7, 1, 8. So I kept it pretty basic, but yeah, I can just drag this and you see we've got those growing along the line. And yeah, no keyframes, just ready to go, have complete control over that. And I was able to build that a lot quicker considering the overall setup. throw that same smooth in there. I'm not going to clone the spheres because that would just be a waste of time. You saw that process already. Smoothing, smoothing, smoothing. Boop. Yeah, smooth those out. Subdivide them as much as we want to. Let that grow through. Let me see if I can track down the file just for fun. Where is... Here. Okay, yeah, no audio, but I just want to scroll to... Actually, yeah, right there. So I just want to show you that. So yeah, if you spend a little more time, you can make it look all super smooth and blobby like that. So yeah, this was literally inspired by that animation from that Netflix show called, it's not a show I've watched, called The Crown. So yeah, just throwing that out there if anybody's interested. I'll save that file as well. All right, moving on to the next question. Stop the flicker in the mesh. That's a fine question. If we go back to the first one, yeah, you get the volume builder and you're just going to end up with like flicker as the volume. It really goes to, this one's probably gonna have a reasonable like lack of flicker, but the biggest thing is your volume mesher. So cranking up the detail, which means decreasing your voxel size, but that is like an exponential growth thing. So right now, if I take a look at this, okay, you see this geometry, but that geometry is going to tend to be a little inconsistent. One important thing would be grabbing your density and cranking that up, which means it samples it more often. So you'll see there that this was on like 0.1, and you see, okay, the geometry looks a certain way, but if I jump it up to 1, it changes. If I jump it up to 2, it doesn't change, which means it's now sampling so much that it's coherent, it's consistent. So that already will help with some of the popping that you might get. But beyond that, the only suggestion I have is you have to decrease your voxel size. So I'm going to push it way far, and now you see there's way more subdivisions, and way more subdivisions means that things like our smoothing, those need to happen way more. So I'm going to say ×2, and like let's do ×2 again. So those have to smooth more and more and more to counteract all of the volume extra polygons. But yeah, just increasing the resolution is going to increase your fidelity. It's kind of, in a certain way, you can just imagine you're increasing your resolution. So if you render out a 50 pixel by 50 pixel animation, look, it looks really pixelated. But if you double that, it's going to look smoother. If you double that again, it's going to look smoother. We're doing the same thing, but with a mesh. Same concept, though. So yeah, that'll slow everything down, but that's the best thing you do is just increase your resolution. But of course, there's the knock-on effect, like we had to change the smoothing to compensate for that again. And I can't crank that up to the levels for us to super worry about it, but I bet that this is going to look a lot cleaner overall based on that. Yeah, even right now, like that's looking pretty dang smooth as compared to what we had a second ago. Yeah, pretty good. So that is my advice. Let's see. Eduardo, welcome. Let's see. I'm going to see if YouTube has a question. How can you move objects the same amount sequentially using a cloner if all their axes are in the exact same place? Sequentially. The exact same amount sequentially. I think I actually understand the question. It's worded just well enough that a complicated question makes sense. Okay, so what I'm thinking we've got here is we'll start simple. Making a cube that can be thrown into a cloner. The cloner will be set to linear mode, and I'm going to say they're all on top of each other. So there are now 50 cubes all exactly on top of each other. So they're in the same spot. We can't use a linear fall off to move them all forward. So let's even do that as a literal thing. So here is a linear field. Tell it to move up 500 units. I want there to be a linear field. And now if I were to pass this through, obviously all 50 spheres are moving the exact same way. All right. Now the question is, do I have an answer for this? Well, the obvious thing that jumps to mind, well, the first thing that jumps to mind is the step effector. The step field layer in this case will enable us to do things based on the index of the object. So now we can see that the first one is getting 0%, the last one is getting 100%, and the middle one is getting 50%, and every step in between. So we've got a ton of cubes, each getting offset via a linear, or via this step effector. So, do we have modes in that one? Not so much. Now, I think the idea probably is you want all 50 of these to move up, but offset a little bit from each other. That's what my assumption is. So first of all, they're really big, so let's scale this down until we can see, yeah, them individually. So again, without, if we blend this down, they're all down at the bottom. Now they are all in the same spot. One thing that jumps to mind immediately would be to keyframe them. If you keyframe them individually, you can get that type of offset. Actually, that's a good idea. Let's do that. So no keyframes, nothing. Grabbing the cube, I want it to be inside of a null. So hit Alt G, and then take the cube, keyframe the Y position at 0, and then at the end, I will keyframe that up pretty far. Oh, that's the scale. Let's do Y position at the beginning. Okay, now, sorry. Keyframed at 0 at the beginning. Now, at the end, I want it to be pretty far up there. So we'll keyframe that up to 500. Keyframe that. So we now have one cube that is going to travel up, but it's in a cloner, so there's actually 50 cubes doing the exact same thing right there. So if I were to select the cloner, if I play, it's going to play. So that's fine. But selecting the cloner, I can now feed in that. Well, yeah, actually, let's put the step. We could do a step effector, but let's do a plane effector and feed it a step field. Okay. So now they're getting offset, but I don't want to be affecting the position anymore. I want to be affecting the time offset. So we're going to offset them in time. So I don't know how far we want to go, but let's play forward a little bit. And there we go. So as I start spreading these out, doing a time offset, we are now multiplying them based on their index and telling them to wait. The last one should be waiting 88 frames before it begins. So now we can see that that begins, and then it will, we need a lot more frames now, about double. The first one is traveling up and then finishing its animation. And the last one is 88 frames offset. And every other one in between is doing that in between state. So now we get this transition between them. So let's make slightly fewer so it'll be more visual. So now you can see that they are each offset in time by keyframing the specific, the parameter you want. So I keyframed the Y, and now it can animate exactly how it is animating, but it's based on this plane effector offsetting its time. So that's one way. If you are staying in the world of, let me save that as one example. Offset in time cloner. Okay, so instead of that, what if we wanted to, I want to control the animation overall with a linear fall off. In the cloner, there's a setting called, under transform, called animation mode. And currently the animation will play. I'm going to say don't play. It's fixed. It's not moving anywhere. So then, let's reset this and do this step by step. If in the fall off, we are now offsetting via the index again. If I hit play, you'll see nothing animate, nothing's happening. But instead now I can say there will be a time offset, and as I drag that, this is now saying exactly how much time has passed, but it's literal. Like as I do this time offset, it is stuck to that. It is stepping through as a, I'm trying to think of the best simple way of explaining this. If I do a time offset of 90, the first one is offset by 90, but then the last one is still getting offset by 90, and we haven't gotten there. It doesn't get enough time to move. Can we then use a linear field and offset that? That's what I'm not sure about. Like it does, yeah, you can see that that will offset that one, but it's just a weight on top of it. That's set to max. If I set it to normal, all of them move together again. So really we need this to multiply in the linear field, maybe subtract. Yeah, maybe subtract based on the linear field. So now the linear field will pass through and offset them. But it needs to go double that amount if we want to complete the animation. To complete the animation here, do we have to double the time offset? No, maybe. Yeah, it's probably more than double. That's offsetting it. Yeah, things we're gonna get lost here because it gets really technical and specific. Like we say 90, and now potentially we could unclamp the linear field. Like if I say don't clamp, yeah, what happens then? Okay, yeah, unclamping is a cleaner way to do it. So now let's go nice and slow. What do we have? I'm saying offset time by 90. We already know that a single cube takes 90 frames to do its animation. In the fall off, I now have a linear field, and it's just saying, hey, like you're at 0, you're at 100%. That's what it's saying. But we unclamped it. So in the remapping, I said don't clamp, which means as I continue pushing, it's now getting 200%, 300%, 400% as it keeps on going, additional lengths. On top of that, I'm saying, but then we also have the step effector, and the step effector is saying like, hey, the first one is 90 frames ahead, but this is set to subtract mode, meaning the first one's actually at, I think, 0. So now as our linear field pushes through, the first one gets to go, and then as we get to the end, it's only partially done, but because we unclamp the linear field, we can keep on pushing it even beyond that. And now this is entirely driven via fields and any fall off, the linear field obviously just being the simplest one we could use. But we can now have that pass through and just affect that with an unlimited distance. So yeah, that is what I wanted to go for. Move on X. And we'll save this as next version. And I think that's as far as I'm going to go unless there was clarification on the question. And there was not, so I'm going to assume it worked. Okay, back to Twitch. Second that, yeah, the Rocket Lasso Slack channel. If you are not familiar, let me pull it up. If we go to rocketlasso.com, you can go to the community page and you can click to join us on Slack, and you can come join all these awesome people in the chat in the Slack channel. So you should totally come and do that. Anyway, ooh dear, Dean seconding Mick, how to get a model walking around a hilly terrain naturally. I essentially don't have an answer for you. I'm a big fan of like keyframing everything, like literally animate the walk, and then, you know, if he's stepping on a hill, if the character's stepping on a hill, like animate the foot lower, do it manually. Cinema does have the character animation tools, the C motion, and that is supposed to have certain features that it can detect the distance of the ground, but it's not going to stumble properly. It's not going to like super shift its weight. It's just that the foot will go down a little bit further to reach that other point. And I mean, this literally goes to, there are all sorts of AI-based simulations that are figuring out how to make a character walk. And then you have procedurally based animation, which is like in the video game where it like there's actual like calculations happening I'm trying to even think of how to explain. Let's make a landscape. Like imagine, I'm gonna make it very low poly. Okay, imagine that we have a character who's stepping here, like his right foot is here walking that way, so his left foot goes to step here. So with procedural based animation, you might even have motion capture, but then you'd have a secondary IK system, and the IK system, the left foot would shoot a ray out, and the ray would hit the ground here. I don't have a good pre-built setup for us here, so here's just a visual aid. So here's just the left foot, and the left foot wants to land on this baseline, like on the same level where the main animation is. But the IK system will be driven by where this is going, and that would shoot a ray or like a laser down and be like, oh, actually where that collides is here. So then it would say, okay, drag. I know we got this walking animation, but make the IK move further down until it collides with this, and then it would naturally, via algorithms, transition as it takes its next step to move back into its natural position and just blending between those. So to accurately do that type of thing is full on deep, detailed, dynamic, and like simulations. There are different simulation systems out there, not necessarily specifically for Cinema 4D, but all sorts of video game engines just do this type of thing. So yeah, don't have a yeah. So I don't have any specific system we could do. We could spend time and build a rudimentary something, because it's like you can build a mechanical spider. Well, build a spider rig where the spider would be taking a step and it would determine where the next destination would be, and it would do an arc until it gets to that new location. There's a lot of probably programming even involved in that. So yeah, fancy, complicated things. Let's see. Somebody's seconding another Mick question. So let's see what we got there. Copy. Paste. Mute. Okay, I like it. So this is a fast-forwarded animation of sheep getting herded in a fast forward, but it's pretty wonderful. Like, that's pretty great. Let me think. It's adorable. I mean, it's cute to watch. There is, I mean, once again, I love that this is a real life thing. It's a live action thing, so it's cool. In reality, we would have to program in agents, like, and it is possible in cinema, even just in Xpresso, to program agents to have some level of intelligence and make certain decisions based on its environment. I'm trying to think what is the most basic. How would we build a whole rig of them? I mean, I love this concept. I feel like this is a 2-hour question, potentially, which is, like I said, I want to do a lot of questions. I wonder what I'm trying to think of what the most basic version of this might be. And I can think of approaches. So I wonder if we can make something very basic and if we'll be able to make a bunch of copies of it and have it kind of do something. So this cube is going to be our sheep right now. And we'll even make it white. And let's turn on some SSAO just so that we get a little bit of grounding on the ground. And if we're going to spend some time here, let's make sure that we can tell that they are grounded by turning on a soft shadow, turning on shadows. So there we go. Get just a little bit of grounding. Okay. What is Z+? Okay, that's Z+, so it would go forward that direction. Okay. Let's just call this the lead. Well, that'll be our lead sheep. Okay. It will be, that and the ground will be dynamic. So let's say simulation, rigid body. We do need friction on the ground, so that's fine. I want it to lose energy. But do we want ground friction? Maybe not. I'm going to say 0 friction and then put on a bunch of linear damping. So let's do 90% on our linear damping. Okay, so that's the basic idea right there. Now, simulate forces wind. I'm going to make the wind a direct child of the lead sheep. And I'm going to tell its dynamics to only include things I tell it to look at. So I'm going to say, yes, include that wind. So the wind already has some strength. If I hit play, you're going to see that this wind is forcing it forward. Okay, that's pretty much exactly what I want it to be. We need a lot more frames. So you can see that that wind is forcing it forward. If I turn off the wind, it's going to slow down because we're draining a bunch of energy out from the scene. So we just have this wind that travels. So this is supposed to be the lead sheep, and that pretty much means it'll keep on going forever. Let's make a duplicate, and let's just call this one sheep. So that's a regular sheep. How do we see? That's the thing I'm not taking into account. We can do it from 1, but with code we could do certain things, and I can't just casually put together code. I can hack things together, but it wouldn't be pretty on a stream. So let's keep it very simple, and we'll, just as a way of exploring the idea. So let's do programming tags Xpresso. It's going to take a second for that window to pop open. All right, here is the lead sheep, and here is our new sheep. If the lead sheep, okay, so we've got these two. I'm going to output the global position and the global position, okay? So that's exactly where they are in the world. Then we can search for a distance. So here's a distance calculation, and that can be fed their 2 positions. So that will now output the, we're going to need some numbers here. And my favorite way, there's ways of doing it, but my favorite way of doing this is just make a text object. And that will be our feedback. So if I drag this text in and I output this into the, what property is it? Separate letters, I don't even know. Oh, it's called text spline now. They changed it. Didn't used to be called that. I think it used to just be called text. But anyway, now you see I'm outputting to that. So these two are colliding already, so let me pull that away. And now you'll see that that is always in real time going to be saying the distance between the two. It's going to change slightly because they're moving slightly differently. But here's the idea. That is now outputting a distance. We can say, let's make a constant. So this constant is just a number we type in. So I'm going to say, how far are they right now? I'm going to say 50. No, let's make it more, 75. So 75 is a constant I've got right there. If we're going to stay organized, which we don't have to, I have several things I do to keep myself from going crazy. One thing I do is whenever I'm importing, or whenever something's from the object manager, I make it green. And green just means like, oh, that's something in the real world. Text splines are really easy to miss, so I always make it a bright pink because that's something I'll move around constantly. And now we've got our nice little Starship Enterprise. And then we've got our constant. I usually make blue programming ones, but let's make this a bright blue, just meaning that's kind of a setting that we can go change. Okay, so there's a distance and here's a constant. So here's the thought. I want to compare. So here's a compare. And what is it going to compare? Well, it's going to compare this threshold, so 75, to this distance. If, and then it's always a pain to remember the direction. So remember, 75 is the first number. So if 75 is smaller, let's say smaller or equal to the distance, this now becomes true. So if this gets further than 75 away, it's now true. So let's do the simplest version of this. I'm going to say this wind is stronger. It's stronger on our follow. Let's rename it follow sheep. Follow. That's our follow. So we got our lead sheep and our follow sheep. So its wind is twice as fast. The wind, we now have a compare that's going to be true or false. If 75 is smaller than the current distance, it's going to output true. So if it's true, like so essentially what I'm saying is if that sheep falls behind, this is outputting true. True in this case means turn on the wind. So I'll just say it controls the enable. So we're now enabling the wind on or off. So currently you see it's off because it's really close. It doesn't need to do anything. This wind is output into the scene, by the way, so I would make it green. Okay, so that is now off. So if I hit play, it's dead, and then suddenly it's going to turn on. But because it's quicker, you see it's going to keep turning itself off. Let's make that wind even stronger, so it might have a little overshoot. So it moves away, and then the wind's like, wait, I gotta catch up, I gotta catch up, I gotta catch up. Now, obviously, we need some sort of delay here. Maybe I will not have quite so much damping on it, so maybe it can, I want it to like catch up and then stop. Yeah, it's a little better, but not amazing. But yeah, there. Okay, so now you can see it's every once in a while it's like, wait, I gotta catch up, wait, I gotta catch up. So along these lines, if we are continuing to build intelligence, you could imagine, let's make our lead sheep, well, how do I change its direction? There's ways of doing it, but let's just, I'm gonna put a random vibrate tag on there, and let's do some rotation. And I can say it can go up to 720.1 as a speed. So that means this one's gonna be like constantly moving around and choosing new directions, just super randomly. And now the other one just ran away. But that's because our follow sheep doesn't know what direction it should go. So how do we build intelligence into that? Well, the simplest thing ever would just be put a target tag. The wind should aim at our lead sheep. So as our lead sheep just wanders around to different places, so it's going to turn, this one is going to automatically turn, and now the wind's like, oh, I want to catch up. Like, and then, oh, I want to catch up. So now you see we've built a very simple follow system here. So let's build just a little bit more intelligence in here. That will be, we are enabling this, okay? So this is saying if it's closer than that, enable the wind. But I'm going to say, let's make a constant. And I'm going to say, hey, this constant just means it's a bool and it's on. So it's saying, hey, it's on. So that means turn on, just become true. And this will now output if it should enable. So I'm going to say on. So when this condition is met, this executes. So it turns on if 75 is greater. So it's going to stay on. And that will stay on. So it's just going to turn on, and now there's nothing to turn it off. We're saying, hey, stay on all the time. So then let's make a turn off condition. So that would be I guess we'll need these three again. So what's the off condition? Well, this constant says, well, I turn things off. When do I turn off? Well, it will turn off when we need another constant. So when the distance is when it gets close is what I'm trying to do here. So if it's closer than 40, let's say, I don't know how close the sheep can get. Let's say 30. So if 30 is bigger than the distance, that means we're close enough. So yeah, if 30 is now bigger than the distance, make this true. This can now execute. What's it executing? It's executing saying turn off the wind. That's the idea. So now the wind should turn on and off based on two different conditions. Entirely possible we've messed it up, but let's see. Okay, it suddenly turns on and it smacks into it, but turns itself off, and it smacks into it. Now that it's going to stay on for a while, we can slow down the wind. It doesn't have to be nearly as strong. So let's see what happens. So this turns on. It's going to be like, wait, catch up, wait for me. And then it catches up, and you see the wind turned off, and now it's going to wait, and then suddenly it will reactivate. So now we've got two different numbers. We could say, okay, it can fall further behind, so let's go 125. So now it's going to wait quite a while before it activates. Let's give ourselves even more frames. So now it's waiting, and it's like, well, what do we got here? Okay, it turns off. And now it's waiting until it's, it's waiting until it's 125 away, and now it's on, it's chasing it around. It's like, wait, and now it suddenly got close enough, so it turns off. And now it got too far, and now it's going to be, wait, and it's going to catch up again. So, yeah, so it's now it's a rig for activating and saying, wait, I want to catch up and go hang out. Now, as far as getting a flocking thing going, I don't have a good system off the top of my head to have them all detect each other, because really I'd want the lead sheep to... I'd want every sheep to not have to follow the lead one. Just one of them would have to be close enough. And if any ever get too far from another, it would follow. But, with the basics of what we do have set up here, we can just make as many follow sheeps as we want. So I could just make a couple of these. And they don't care about each other. They only care about the lead sheep. So let's make the lead sheep luminant. Just so he stands out in the crowd. Oh, does that not show? All right, we'll make it the red one then. It's still not showing. Is materials turned off? Why? Oh, we ran into this recently, didn't we? It's something like, we literally ran in. I'm getting like crazy deja vu, but like a couple, I think even this season, we found out that the material won't update in the viewport while the Xpresso window is open, or something like that. There's something that we did that causes the material not to refresh, and I can't remember what it was. Dang it. Well, it's still not updating, and I don't want to spend any time doing it, so let's just turn it red. Okay, so now we just got 3 of them each doing their own, or 4 of them doing their own thing, and each of them independently is deciding when they want to activate and suddenly go crowd around the lead sheep, and then they're going to turn off, and then the lead sheep's like, leave me alone, and then independently they all start chasing. If we begin to hide the wind, which is very visually distracting, yeah, we can now see them wanting to catch up. So the point being is we've now built a rig with some simple intelligence, and I think that should work. Let's see, he's still hanging out nearby, and that one turns on. Like, wait for me. I should probably stop this one from turning quite so often. There, you should be a little more constant. That one broke somehow. I'm not sure how that one would deactivate. Oh, it could be that they dynamically fell asleep. That's probably what's going on there. You can't fall asleep. There we go. Yeah, it just fell asleep. That sheep fell asleep. So yeah, there we go. A little bit of intelligence in them where they're all like, hey, every once in a while they want to go and catch up because they got too far away from the lead one. And we can make as many of those as we want, and we have a bunch of independent rigs going to make them do their own thing. Now, we could, if we are simulating that, would there be completely unrelated ways of doing it? Yeah, of course there would be. I'll save this for anybody who wants to tinker. It's a fun little simple Xpresso rig. So let's do a not Xpresso version. Sheep Xpresso. Let's do a not sheep. Or I'm sorry, a not Xpresso version where I'll just take a lead sheep and a follow sheep, and we just have our dynamics tags going. No more of any of that. Okay. So, well, I guess I don't think we even need a lead sheep anymore. Well, maybe we do. I don't know. We'll play around. The main thought being we can make a bunch of like field flow stuff. So using a simulate field force, we can make whatever directions we want going around. These, I can say forces now exclude things, so I should accept everything. And the field force can be fed directions. So in this case, let me think. I gotta refamiliarize myself with what you can do with a vector builder, with the volume. With the volume builder, you can also go into vector mode. So volume vectors, because that would give us some nice flowy directions. There's a lot we can do. Let's make a helix. Set that to 0. Lay it flat on the ground. 0 height. 0 radius. Increase the end to be quite large. Double the spin. Okay. Just a little something there. Feeding that into our field object tab. And telling the field force to display 100% of the lines, 0 on Y, 2000 by 2000. And the vector line be longer and be a little up in the air. Okay, so a little subtle, but you can see we get these. Wow, that's really hard to see. In the field force, I want these to travel along the line. By default, when I drag the helix in, they're traveling around to follow the direction. So it falls off in the power, but if we say offset 100%, you see I got full length lines here. So that gives them an overall direction to go. That's all fine. Obviously, that, you know, incredibly simple setup to throw the basic sheep into a cloner. Now we get a whole collection of them. They're all independently dynamic. Hit play, and now they should start swirling around. They all want to go to the center here. Should be what their goal is. The Helix, let's try feeding that into a... I don't know how good of an idea this is. You know what's a better idea? I'll just make a cube and clone a cube that is rigid body simulation collider body. I want to clone that onto an object. The object will be the Helix. There, we got a bunch of those. And we can make them based on the step. And now you see I get a bunch of them. And if I increase the correct direction, which I just happen to guess correctly, maybe not the best idea because they're going to get... I just utterly lost internet here for a few minutes, unfortunately, which is very unusual. That doesn't really happen. Okay, what did we lose? Did you see... I know it would have taken Crossfader a second to text me, and thank you for the heads up. I made this wall, and then using the field force, I made a second helix, and that helix is put using a radius with a negative direction, inverted direction to push them towards the center. And once that's added on top of this one, things want to stay away from the wall but still twirl inward. So hopefully that catches it back. If that makes sense to everybody, somebody let me know if I've missed a detail. So I'm just making a few extra sheep via this cloner, and I'll move this out to the outside. And let's hit play and see what we get. Hopefully all of these will start moving in. Some of them might escape out the outside, which wouldn't be surprising. Yeah, because they were outside the spline. That's completely fine. I want to trap them all inside, though, so shrink that down a bit. And there they go. Now they should all... We got more sheep trapped into the center, and they should want to stay away from the wall, but they want to travel through the entire thing as well. All completely fine. Now, we don't want the sheep just bumping into each other, so let's make a simulate forces... No, wait, where is it? Under dynamics, yeah. Force, and this force object can be used to make everything get attracted to each other, but it can also be used negatively to push them away from each other. So as soon as I push that, you see they explode away from each other. So all of them want to travel through, but with this negative force and them being so small, this force is enough to mostly keep them pushed away from each other. And what we can do is say they're pretty tiny, so let's make the radius pretty small, but then start making the strength really strong. So that's going to really try and start, and we can keep on pushing this like really far. So if we do 100, then they have the small radius that they really don't want to get on top of each other. So let's see if that's enough to, there we go, it's working pretty well. And one sheep escaped. So that is the plan. Dead back, okay. Just checking that text. Okay, so now you can see we've got a cluster of cubes, or our sheep, all traveling through this line, and they're keeping a distance away from each other, which is actually a really nice setup. Like, it's really cool to be able to push things away from each other. I'm trying to think of what if we wanted them to have a particular direction. This dynamics don't inherently have a frontal direction. That's just a thing. But if we make a simple dynamic connector setup here, that we might be able to get one with a little bit more direction to it. So my thought being, let's make, actually this could be cute. Let's make 2 cubes, and I keep on messing with the wall. I gotta stop doing that. The wall goes below, the sheep go above. Okay. So here's the thought. We put the sheep into a null, and we make a second one. Turn off the cloner for a moment, and yeah, there's our sheep. So let's make this the head of the sheep, and we'll pull that forward, and we'll make that one black. I don't know, the cloner will probably kill off these colors, but we make that one black. And now we've got the body of the sheep. I'm gonna make that a little bit bigger. It's already adorable. Okay, so if we connect these two, even in the simplest way possible, if I say a connector, it'd be kind of nice to make the head be able to swivel, so maybe I will do that. So if we spin that 90 degrees and we pivot from there, that's the idea. I want I guess I would become a child of the body. So that becomes the body. And that will connect the body to the head, right? So does that work? Does that stay connected? Seemingly, yes. So the body, yes, it's dynamic, but I'm going to say include nothing. So now that field force that's pulling it forward, this body isn't being tugged by that at all, but the head should be. It's got its own dynamics. So now the head is getting pulled forward, but the body is left behind. But that means naturally that the front should be kind of front heavy. It's going to tug it forward, so that gives us a inherent direction. Yeah, we just stay over here for MPB Mike, I'm assuming. If you can post in the YouTube the Twitch URL. Let's see if I have that pasted. Yeah, if you can post that. Oh, no, you're not going to be able to put a chat. But if you can go over there and say, just head over to Twitch, I'd appreciate it. It wasn't because of my internet going away. I couldn't get back into that chat room. But anyway, let's stick with our dynamic sheep. So we've got our cute little dynamic sheep. It's in a null. That can now be named sheep. And now we can make the entire cluster of them. And there's, oh yeah, I said the cloner is going to take over the color. So we do need to hopefully make a material that actually will remember itself. Yeah, for now, whatever reason. Like I said, I think the Xpresso didn't like something about it. There we go. Cute. Sheep, yes, but more spacing. More spacing. Okay, we got our army of sheep now. We'll spin that a bit and get them a little more trapped so nobody escapes. That's the idea. Okay, reactivate the wall, and let's see what we get. So hopefully we've got our adorable little army of sheep, and they're all getting tugged forward, and they're all pushed away from each other, but yeah, they're moving forward pretty well. It's all working well. The head, the body's dragging it behind, which is fine. I'm going to increase the power of, well, here's that push apart force where I do want that to be stronger. Maybe we'll increase the radius a bit, so we'll say 30 and 60. And it needs to be stronger apparently, so let's double that. Let's go 500. Okay, that's starting to spread them out a bit. And our overall field force is pretty weak, so let's triple it. So now it should be three times the power, staying away from the wall, but also pulling them forward. Now I do want them to stay away from the wall, but it doesn't have to be that much, so we'll decrease that radius. Layer 140. So they can get a little closer to the wall, that's the point. All right, so each of them is independently doing their own thing, traveling over that way. Once you get into this world, it's really easy to really start fiddling around. I want these to keep their distance a bit more. There we go. Yeah, okay. As soon as they spread out right, then the vibe gets way better. So yeah, all of them are doing their own thing. That's working great. They're flowing forward, and they even have a frontal direction, which is pretty cool. So now let's start trying. I'm trying to think of what the best dynamic way would be to make them stop every once in a while. The only thing that pops in the mind isn't particularly dynamic. It's merely making a random field, and the random field. Actually, let's make a solid, so that is set to normal, and that completely just overrides everything. And I'm going to give it no direction, so it's pretty much like there's no power there. And then that will get masked out via a mask, via this random field. And that random field can now give it some sort of power. And pretty much I'm just thinking we'll make some dead zones. So how do we represent that? Well, under remapping, we can go to our curve and crank up the contrast like a whole bunch. And now there should, yeah, as I do that, you're going to start seeing some patches. The noise is probably pretty small, even though this whole scene is pretty small. That random field can be made larger. And as we go larger, we should start seeing there we go. You suddenly see it's like chaos, 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 and pattern emerges. And now we can start seeing the actual scale of it. So there we go. The idea being we can now make dead zones that when they go in there, they're just going to be like, oh, there's nothing pulling me forward. That is controlled via this pretty strong remapping. So we could make more or less dead zones. So we can do something like that maybe. Start seeing these little empty patches. So in general, they want to move forward. Right now, there's going to be dead patches and there's no animation speed. So let's just see what happens. Some of them are going to, well, they're super pushing apart from each other, which is cool. But now we got the dead zones. So they're probably immediately going to kind of find areas that they're like, oh, I'm just not moving. So they're kind of all just like, oh, what am I doing? But then one behind might boop one forward to keep going. And yeah, but you see, eventually they're all going to find these dead zones and not be moving. Were they all intersecting in the beginning? That initial explosion is bad because some of these are starting to collide with each other and the heads are getting stuck inside the body. Oh, and are the dynamics falling asleep? I thought they'd still be, yeah. Yeah, they can't fall asleep. So yeah, let's just make sure of that. They're a little on top of each other for how strong we made that push apart force, which is quite strong now. That's a little calmer. Less heads seem to be getting stuck inside of bodies. Okay, so they're going to find different dead zones. Inside of that random field, we'll move the force up to the top, we can give it a little bit of animation speed. So yes, it'll find a dead zone for a little bit, but given a little bit of time, that dead zone will move to a different location. So now all of them should like slowly work their way forward, randomly doing their own thing. Now, in theory, we told that dead zone to just be, well, right now it's a very large dead zone. That's entirely driven via where we told this to go. So if we scoot this over, then in general, the dead zones are a lot smaller. So in general, we'll get more movement forward, but they will be slowly moving around doing their own thing. But when they hit a dead zone, it doesn't have to be a dead zone. It could be a different direction. It could be a completely random thing where they scoot over and go do something else. But all of them should now want to go forward, and occasionally they'll fall asleep. But as the animation is slowly going, then they'll keep getting tugged forward. That's the idea. It's a bit slow right now. Let's give them more power, about double it. Go a little bit faster, everybody. Of course, the doubled power probably means that they're going to fall asleep a lot less often because the dead zones aren't quite large enough to catch them. So with the extra power, we could add extra energy drain. So let's do a 90% energy drain on the body, and then the head, let's do only 5. So the head can kind of stay moving and wiggling, but the body's constantly like draining lots of energy out. So we just get the combination there. And yeah, they're just going to keep doing their thing. We just find the right calibration here. So yeah, that can hit a dead zone and stop. But when they are moving, they're moving at a decent speed. And yeah, so that this is a non-Xpresso version. There's no intelligence to this one, but you can get a kind of flocking behavior going as they all do their thing. You could even, I know we're using those field forces in a really strong way, but you could use the field force. I wonder if we can, I'm going to tell these heads that they can't go inside the body. So I will scoot the head a little farther forward. That's the body. Let's scoot the head a little extra further forward and then tell the connector that don't ignore the connections. So now the head is connected to the body, but they can't pass through each other. So yeah, the head can still turn. Yeah, the head can still turn plenty, but it can't go inside. But yeah, right now they're all moving kind of independently, doing their own thing, and they're being told don't get too close to each other. But there is a cool thing you do with field force, which is, I do kind of want, I mean, they are still getting on top of each other. It's such a tricky balancing act. I want to see what is the, I want them to be able to slip past each other. How much friction do they have? I think they have 0 friction, right? Yeah, 0 friction. We could give them more bounce so that when they hit the wall or each other, they're like, whoa, I'm out of here. But we don't want the head bouncing off the body. So maybe the head has very little bounce, but the body has a bunch. Anyway, what I was going to get to is an idea of them still wanting to stay clustered together. So let's give them a little bit more room. Grabbing the original Helix, T for scale, just scale that up a bit so those roadways are a little bit larger. And our sheep, gather up a little bit more. We'll give them a little more space. Pew. Adorable. Okay, so now we've got all of those going around, doing their own thing. we could potentially try and keep them in a cluster with a secondary field force. So this is our force negative, but we could do a larger force positive. And the idea here is we make, currently they're pushing apart by 500, but we could say, actually, you are attracted by 200, but not in this close range. So it's weaker, but it's larger. So if I give it like a range of, let's say 500, and we're gonna have to find the right calibration here, but you now see that we get these clusters of sheep that are all like getting sucked in. Yeah, I mean, weird. That was not the intent. But let's weaken this significantly. Drop it down to, I don't know, 50. And let's see what happens. Yeah, so it's in for a square, but it's probably got to be real weak. The idea being is that we have a very large but much weaker force that keeps them all wanting to stay kind of generally in a group, but it's super overwhelmed by this really strong negative force that has a small distance. So if I triple the power of that, but shrink the distance a bit, and yeah, they should maybe want to stay as a cluster a little bit more, is the idea. And generally, you know, so many different things we do with field forces. We could just make a second, let's make another noise, and it'll be below this one. But this random field, I'll make, let me show you correctly. Let's set that to normal, give me the power, and that's all these crazy directions, but let's just keep on increasing it until we get some coherent noise, and we'll give it some decent speed. And yeah, that just becomes something that can overlay on top of everything. So we could literally overlay. So the sheep could be getting some more randomized directions, which right now it seems a little overpowering. They don't seem to have a particular direction they want to go. But then we could just start, it's a little slow. Yeah, so they're all just kind of wandering around doing their own thing. And we'll just start pulling back on the power a little bit until we get that nice equilibrium of, you know, they'll get some variation in the way that they're moving, and in general they still want to go the main way because it's overlaid and it's not full power. It's a bit uniform still. Let's increase that scale more. The overall power, because of some of these combinations, I'm going to speed them up a little bit. They're still getting a little bit close for my taste, so let's weaken the overall attraction. The negative power, we have it pretty strong, so I will increase that a bit. There we go, get away from each other. And yeah, it just goes to layering, 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 and we get some hopefully crazy looking kind of flocking behavior. So the emergent behavior is super interesting. When they all started like crashing into each other, it got ridiculous. It is amazing just by putting like two different boxes. It's amazing how immediately you kind of start getting character where like they do have a direction that they move forward. And there almost starts to be a personality to them overall. Funny. Weird. But I like it. Let's make the fences a little bit thinner. Change the color. So yeah, you know, field force here. I mean, the important thing to remember is that this is fully dynamic. We're running not quite at real time, but not super slow. Let's give it, I'm going to try doubling the speed and just see what we get. Because, I mean, the other thing we saw was also time lapse. They're probably not going to stop here if we put the speed up too much. But keep in mind that we do have that kind of speed setting if they're going a little slow for us. The bodies wibble and wobble a bit more than I want, so we've got angular damping. I'll calm those down so there's less wiggle and wobble. But with any luck, we could put obstacles here. So if we steal the dynamics tag from the floor, and I move the cylinder here, the sheep can't get around that. They're just going to bonk into it, but they've got a bunch of randomness moving. So you see that they will go around it eventually. So you can just put obstacles in and they will work their way around. You could put some negative attraction around it. We could do some various shapes to stop those from to actually like flow around it, because they wouldn't naturally aim for it. So in the same way we're saying like, hey, avoid the wall, we could say, hey, avoid various shapes, like in a really easy way actually. Here, I'll show you that because it's actually pretty cool. We don't need that lead sheep anymore. Although, yeah, there's things we could do potentially to... oh, that would be fun. Yeah, maybe we'll sneak in like a couple of herd dogs here to push everything away. So let's get rid of that lead sheep for now. But what I wanted to show you is we're currently doing a really good job of avoiding this wall. But we could avoid other things. Oh, there's going to be a big old sheep traffic jam soon. But here's a thought. If I were to make something like an end side, lay it flat on the ground, give it a couple extra edges. And it's a little big, so we'll shrink it. If I want to put that into a connect object so we don't have to keep on relinking, and then we'll just call this avoid. We can put whatever shapes we want in there, but the idea being I could put this end side anywhere I want, because in the field force I will feed in... Oh, I don't have the dead zones in, but at this point I just want to see what happens when all the sheep get trapped in this one spot, and then we'll continue. So let me check it out. Uh-oh. Uh-oh. Yep, sheep traffic jam. Once they all start pushing in, even the negative force isn't enough at the current settings to stop them. So, yeah, I'd say they've been penned pretty well. Any escapees? No. We got a straggler, but that's fine. All right. Abusing sheep. Let's go back again. Anyway, so I've got this avoid. The idea being inside of our field force. I'm going to turn on that solid again. So some will stop. Okay, inside of here, I will drag our avoid, and the avoid will come in as a spline object. Turning on our display again, we should be able to see around here that because it's a spline, I have the ability to say you are not a long, but you're a radius, and give it a radius, and you're going to see this radius go. We already know from the wall that we have to flip it to negative. So under its direction, I will say turn off invert direction. So now there should be a radius around this thing that will push them away. So let's see what happens if I move this into their path. So the hope here is that when they get close, they're going to be like, no, I can't get close, and they'll avoid it. Yeah, you see it? That one got close. It's like, no, I can't. And now it went around without ever bonking its head in. And all we have to do is kind of calibrate that to the right setting. So right now we're on avoid normal, and it's a distance of 100, which is actually quite a bit. But let's, I'm going to make it 3 times as powerful. Yeah, it's 3 times as powerful. And yeah, now you see they're just naturally avoiding it. But what's cool about this, and I love doing this type of rig, is I can just duplicate that end side, and now I've got a completely unrelated end side. So I can just make another one here, and you see immediately I could use this to like push the sheep around. Because it's seeing the connect object. So we could just keep on modifying this however we want. So even though, I'll turn off the field force visibility. Yeah, I can just make duplicates of that. So if we were doing, you know, different shapes, different silos or whatever, they can just become children of these end sides, and those end sides actually represent them not being able to go through. But it's actually doing a direct avoidance. So where's that end side? Oh yeah, the I wonder if that still works, because there's a thing with a connect object that as soon as there's any geometry inside of it, it stops seeing it as a spline. So it's something to keep in mind. But yeah, those should be avoiding and going around, and we've still got our sheep going. Now that I turn on that randomness, you see a bunch of them are kind of straggling and it's going behind. But we do have kind of our adorable little herd of sheep traveling around doing their own thing. And I mean, we are building a surprising amount of intelligence into this, in spite of, you know, not coding anything. We're just using the field forces, and it just unlocks so much power here. Cute. Okay, so then the last thing I kind of want to do is, you know, let's do maybe a herd dog type of concept. So let's see, how do I want to do it? We got the sheep. I guess we can do an entire second cloner, and this one will just be the dog, and The body of the dog, we'll make him brown. We need very few of them, so we'll just make 4. And the head, yeah, the head can be brown as well. Okay, so those are our herd dogs. We'll make it a little darker. It's a little neon. Okay, so those are our herd dogs. My thought was, does this work? Maybe that's not as easy as well, we would have to make it editable. I kind of wanted to put like just some giant negative attractors on them so the sheep would super avoid them. But the negative attractors won't dynamically link independently. We could do a large field force, but that can be challenging. The easiest thing to do would just be, we'll just make 1 dog and we don't have to worry about it. So we'll just see what happens. So here's 1 dog. And he will get a field force. Just do a big old spherical field. Keep it simple. So spherical field. Drop it as a child of the dog's body. And now we get that. And I can make it whatever size I want. So let's go like that. And let's see what happens to start out with. Oh, and we could be a completely separate field force, which is probably a good idea because I don't want the dog to be attracted to its own spherical field. Yeah, I think we have to do that. So delete that one, and we'll make a brand new field force. Even that, like with all the complication we have in that field force, but now we can just be like, we'll just make a separate one. And yeah, that goes on the dog. Oh, I do move the wrong thing. Move the correct thing. Okay, field force. Let's call this one field force dot dog. It will get that, and we'll give it a bunch of power. So let's go overboard. So we'll say 222, and that should do it. I'll just say that the body, this dog, it's got the same behaviors as the other one, but the head, which is the exclude, excludes nothing. I will exclude the dog force from it. So the dog isn't affecting the dog. So let's see what happens. Ooh, okay, the sheep are beating up on the dog to start out with. Okay, field force, sphere. Oh, they're attracted to the dog right now. They like the dog because the spherical field needs a direction invert. There we go. And now suddenly they run away. And now the dog's free to wander around. So, yeah, so this just goes to the dog has this field force. We can make it whatever scale we want. And the field force dog just needs a certain amount of power, which it seems to be pretty good. But let's go a little bit larger. Well, let's just see. Let's go 555. So it's a really strong force. And you see they definitely don't want to get near the dog. But I think something that might be fun would be randomly making it strong or weak. And we could do that by keyframing it. This would be a good use for Grayscale Gorilla Signal, but keeping this vanilla. In the dog field force, what if we make a very large random field? And you see it's a big mess right now. But if I start increasing a whole bunch, like make it super consistent, and set that just to multiply. So now it's multiplying on the attractor. So that should randomly make it strong or weak, giving it a significant amount of animation speed. You see, suddenly they ran away, and then they might forget as that cloud of noise moves around. It's like, oh, it's okay, they're cool with the dog, and then suddenly they don't want. Yeah, they're going to care and not care about the dog depending on if that field force passes through or not. So let's watch. You see, all of them are avoiding, and then it multiplies more, so they're not avoiding as much. And now they're bullying the dog. So yeah, maybe that's fine, but I'll weaken it a bit. And it'd be kind of neat to make the dog affected more strongly by the overall field force. I'm not sure if that's possible. I will increase its head's mass, which might be a way of doing it, custom density. And let's go 5 and see if the dog seems to have more action. Ooh, yeah, maybe. Yeah, he definitely kind of charged forward there. Yeah. Move, sheep, move. So yeah, you see now I've got this separate agent that has a slightly different behavior and can affect the other ones. Meanwhile, all these sheep are just doing their thing, moving around, like slowly making their way towards the front as a herd, and the dog has left them behind. And yeah, I mean, there's just so many goofy, crazy things we could do to layer this up. A lot of fun. We could really push these rigs far. This is a different type of question. I like this. Let's make his radius pretty large. So the idea being he's going to really catch up to all of them. And I'll even turn off that random for now. So I just want to see, as the dog is faster than all of them, he should kind of force the ones in the back to go forward. See, he's like, go, 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 catch up, catch up. Although along those lines, we, yeah. The dog has a lot of influence right now. Look at them go. It's pretty good though. I mean, like that definitely is giving the impression that the dog is like, no, no, go, go. Like you guys have to move. One even jumped over the fence. Keep in mind that all these forces are 3-dimensional. They're just being held down by gravity. He's in a dead zone, but eventually that sheep will start going around. So yeah, that worked pretty well. He's definitely, and then what you can do is colorize all of these to random colors via the cloner, and whichever one makes it to the center of the pen first wins. But yeah, I love this type of simulation stuff. It's so fun and weird and goofy. So he did successfully get 4 of them all the way around. Wow, just because the forces are affecting the head, it gives such an impression of them running away instead of just being dynamically bounced around. And bing, bing, bing. Pretty fun. I love the look of the whole herd rushing to get away from the dog. Bark, 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 bark. But yeah, I mean, so apparently, what's good to know is that by increasing the density of the head, that it did increase the amount that the field forces were applying. So we could go double, so the dog is like twice as likely to move forward. But and then you could make more copies of dogs. You just have to keep on duplicating the field force. But I can't really think of a way to. I can. There's some convoluted ways of maybe making it so you could put a couple dogs in the cloner. Yeah, the way the kind of snake can flow around. There's a lot of fun there. But yeah, that will wrap up this question anyway. We are getting near the end, but maybe we can sneak in one more question. Ooh, the dog found a dead zone. That gives the sheep a moment to relax. Oh, you know what we gotta do? Because this is super stupid and fun. Let's do dog cam. So we'll make a camera, make it a child. We'll do the body, and then we'll link to it, and now we'll go over here. And we'll get a little bit wider field of view. Now let's rewind all the way. And then, oh, I want to give it lots of power, so let's give the head, that's a sheep. Let's give the head of the dog the 5 again. And let's get a POV doggy cam. Bark, 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 bark. Whoa, calm down there, doggy. He's got a lot of movement. There we go. So there we go. No keyframes. What? Okay, it's more fun to see the sheep freak out from the ground view. Okay, that one leapt over the wall. And he's still going. And yeah, with a bit of intelligence, like maybe a little bit of code, you could totally make these, like potentially have a little bit of intelligence to do certain things at certain times. And even here, I mean, just because we're here and it's fun and weird and interesting, something I'll do is like, okay, we're on this doggy cam, which is fun, but it gets a little nauseating because we're completely perfectly locked to the dog. So here's something I do. I would make a second camera so we know where we want it to be, and here's our secondary one. So let's link to the secondary one and then do something simple like a rigging character, or I'm sorry, a rigging constraint tag, turn on spring. And what do I want to spring to? Well, I want to spring to, let's say, the position of the original camera. And I'll say, a length of 0. And then independently, I'll put another one on, and this one will control the rotation. So we can do different rotation and position. But now the dog, yeah, there's a little bit more freedom for the dog to go, and you see our camera can go crazy. So now I can grab both of those and say, okay, yeah, that's fine, but let's put a bunch of drag. So it's going to calm ours down. You see how we're kind of lagging behind the dog that little bit? And that just, like, that removes so much of the nauseating layer. Like, yeah, feel like, look how much calmer that is automatically because we're taking the edge off from that drag. And you could independently set those. We could have the strength of the positional clamp be stronger, so we're going to be a little bit more on this position, even though there's still some drag. And the rotation is calmed down now. And I love doing this type of thing where you make a camera and then the second one is also a camera and you start interlinking between cameras, because at any given point it's like, okay, like I want to see this in real time, so I can just link to the original camera. It's like, okay, cool, we're locked in. And then we can do the secondary camera where it's like, oh, it's lagging a little bit behind, it's a little bit smoother, and you could layer and layer and layer on top of that, where maybe we do that and now we say, okay, yeah, but then there's a third camera, and that third camera is just a child, and I'll link to that one, reset the PSR, and that one just gets some vibration in it. So let's get some, like, as if the dog is bouncing us around. So I don't want any, let's do some position. Oh, I'm getting a little, well, let's, how far can we go here? How big is this? 15. And I don't usually speed up a, yeah, there we go. So now you see we're kind of bouncing up and down where it's like the camera's stuck to it. And then we could do a bit of rotation here. You don't want to go too far. Let's do, actually, maybe we'll do them on those other angles. And we'll keep it slow, 1. So yeah, there we go. So now, yeah. So look how much personality we can start doing. And so now we kind of got this like camera that's like, now it feels like we're maybe locked to them, or we're camera on the tail of it. And there's all this life as it's kind of bouncing around just through some random motion and some random vibration. Let's turn off the display on that field force. And it's like, okay, cool. So it's kind of like this runny, shaky cam behind the dog. But yeah, okay, but now I just want to see the spring camera, so we can link to the spring camera. And it's like, okay, now we don't have the shake. So even that, we probably name that one like camera spring, and then this one can be camera shake, and that can be camera, locked. And it's like, okay, cool. So here's our smooth one, and we can go to our locked dog camera. So now we're super robotic, and the ability to just smoothly jump between those and go like one layer deeper to get these different layers of animation. I do that. I do these types of rigs all the time for getting control over my camera. And like, look how much life you get automatically by setting it up this way. I'm going to increase the power just a bit of staying away from the wall. This is the wall one. Probably good to name that one wall. And I will push that back to 222 and maybe even give it a little more power. So that just keep everybody away from the wall a little bit more. Come on, dog. You got to get the last one in. Don't let him escape. Yeah, good job. Yeah, you got one in. Only one. Okay, one last time. And then we will see if there's one more question to sneak in. Yeah, I like the shake a lot. That actually adds a lot of life to it. Considering we're just chasing a bunch of cubes around. I wonder. I mean, it's so goofy. You can spend unlimited time here. Let's grab the body of the dog and see if we can add. I don't know if it works with dynamics, but let's add add hair and 10. Yeah, let's go a little. He'll be a fluffy dog, and I want to, in the editor, see the hair lines, but we don't need to see too many. We'll have the hairs. We'll do 5,000 hairs. That'll calm it down a little bit. Yeah, a little weird and stiff, but yeah. Okay, the fuzzy hairs aren't adding to it. It just looks like it's mangy, so. Failed experiment on the hairs. But yeah, we could put some floppy little ears on there, put a tail on, and that would go a super long way. Bark, 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 bark. Yep, so anybody who's interested, this scene file will be available on Patreon. Let's say, I'm going to rewind a few times, get here. We got our dog sheep chasing simulation. Excellent question. I liked it. Yeah, you should totally watch Babe. directed by the same person who made Mad Max, which is the most ridiculous thing ever. Going to propose. Oh, somebody's like jump hurdles. I mean, there's nothing to stop us from putting some jumps in here. In the same way we put the obstacles. Let's de-link from the camera. If we just do something real simple, like make a cube, like the directions are still direction. So if we just tilt that down a bit and do something like that, there's no reason that shouldn't work as a sheep jump. So we can now collide with it. And then, I don't know if this is a good idea, but just as a goof, what if we make a wind? I'll make that child of it. Reset PSR. Spin it 90 degrees. Pull it up. So there's a wind, and then we set that to, I don't know, 100. We'll give it a fall off, a box field fall off. So now if a sheep gets in range of it, it should suddenly get an extra burst of wind so it can actually take the jump. The sheep are not excluding anything, I think, so they should see that. So let's just see if any sheep is interested in our ramp. Well, it looks like somebody will be. Whee! Yeah, look at that. That worked better than I thought it would. Those are some pretty good jumps. I don't know if anybody will take it if they're not being chased by the dog. Oh, one is. Come on, do it. Yeah! Wing! So, yeah, totally cool. Marshall, thank you. Thanks for coming and hanging out. I don't know what is a rating with a party of 8? But in any case, thank you. That's a thing that when people see it, they say thank you. But yeah, we should do more of this type of simulation stuff because it's really fun. It'd be fun to make some renders along these lines too. So many things we could do. I mean, we could have like the sheep munching grass as they go. Like each of these could be erasing out a vertex map on the ground. Like this is only the beginning of what you could potentially build. Ta-da. So awesome. Thank you so much, everybody, for coming and hanging out. This was a fun one. I think we are officially at the end. That is saved. Fun, goofy simulation. I'm glad that we tried a version without Xpresso. So, like, just fields can do so much. There was actually, people were really great about asking questions this time. Keep all these questions in mind for a week from now so we can tackle more questions. I do appreciate all of the links. We couldn't do this without the questions from everybody. Once again, you get access to these scene files on Patreon, as well as 2 bonus streams a week on normal weeks, and discounts on all the plugins. In addition to that, I did just release Mesh to Spline, which there should be, I don't know if there's a link below, but in any case, if you're supporting our Patreon, you get links for that as well. I probably have here's just a link if anybody wants to go check it out. If you want to support me, the best way to support is getting a tool that helps you out. So there's a link to more information or the direct Gumroad store. If you're supporting on Patreon, you get really big discounts on the plugins, and then Ricochet only came out a month ago, so that's pretty recent. But in any case, that's going to wrap this up. The questions were really fun. Thanks, everybody. It was cool. See you next week for a regular episode, and that'll do it. Pull this up and then say bye-bye, everybody.